green egg. Meat like a brisket. I got ribs in there. Finishing off the brisket and the ribs. And I'm just sitting in our backyard, finishing off this brisket and these ribs. But hopefully for Canadian Thanksgiving, you get to eat a lot of brisket and ribs. How many of you guys are eating brisket and ribs tonight? Brisket and ribs. They taste doubly better when you hunted the animal yourself. So what are you guys making for dinner? Brisket.
All right, whoa, all right. I think everybody should be able to hear me. So, hello, my name is TJ Van Tol. There's quite the echo from this thing. And today I'm gonna be talking about something that I personally think is really cool. I'm gonna be talking about building 3 different applications from one code base and all using JavaScript, which is a topic I think is particularly cool. And what I mean by 3 apps, oops, oh, there we go. What I mean by 3 apps is specifically native iOS apps, so apps that you can find in the iOS App Store, .ipa files you can install on iPhones and iPads, web apps that you get from a web browser, really on any device, any platform, and native Android apps, so .apk files that you can find on the Google Play Store, install and run on any Android device. And specifically what I'm going to do is I'm going to start by talking about some of the background behind this. And why would you want to do this? Why would you want to build apps for 3 platforms? Which situations is this a good idea to do this in? What is some of the background? Where did some of these solutions come about? And then we're going to spend the bulk of our time actually looking at a few of these solutions in action. So we'll look at one that's based off of React Native and one that's based off NativeScript, and solutions where you can build 3 applications from one JavaScript code base. So I'm going to start this discussion with a little bit of background and discussing what I think is one of the more contentious issues in the tech world over the last decade, and that's the web versus native debate. Basically, ever since the advent of the iPhone and mobile devices, developers have debated, should you build applications that you can build and run on a mobile device, or is it better to work through native application providers like iOS or Android, or if you go back for years earlier, Windows Phone, BlackBerry would be part of the discussion as well. So personally, I've been on both sides of this equation and both sides of this discussion. I spent a long time as a web developer. I've been writing JavaScript code for over a decade. So I've argued in favor of the web over a long time over my career. If you were in this track before and you heard the talk about PWAs or some of the other PWA tracks before, I'm a big proponent of those solutions and a big fan of those approaches for the web. But in my current role as a developer advocate for Progress, I also help developers work with native technologies as well, iOS and Android applications. And I've seen firsthand how developers, how companies can be successful using native app development approaches as well. And in fact, if you Google my stances, my writings on these issues enough, you'll see that I'm basically a political candidate at this point because I've sort of walked both sides of the equation at different points back and forth and taken various stances. But having spent years with this problem, both on both sides of the equation, over time, my stance on this is really that if you are in a situation where you are choosing between web or native, you're trying to decide between the two, that in many cases, you're actually just better off building both, and that there are a lot of technologies and a lot of solutions today that will help you do that sort of thing. And that's what I'm going to try to convince you of or show you firsthand by building a few applications today. And part of why I feel building for both platforms is a good idea, is because I think everybody in this room, or really any software developer, no matter how much you are a crazy web fan or native app developer fan as well, everybody can agree on a few basic points. One, from the native app perspective, is that native apps provide richer experiences and that a certain chunk of users are just really accustomed to using native app platforms and native app workflows. The study I have up here, currently about 90% of users' internet time is spent in native apps versus web applications. That number actually goes up if you take the internet part of the equation out. I've seen studies that say something like 15 or 16 times more time is spent in native apps when compared to web applications. So whether we like to admit it or not, we just have to accept that a certain chunk of users are really accustomed to going to native application stores like the iOS App Store and Google Play to look for apps and install and run and use those apps on their devices. On the flip side of things, though, the web is really good for reach. The average mobile app gets used more than the average native app, which makes sense if you think about it. The web is not limited by any platform. You build a native iOS app, you're only building that app for iOS users. The same is true on Android. There's different restrictions in terms of versions on these technologies and whatnot. But the web runs anywhere. So there's obviously some big advantages to having an app that can run on the web to reach those users, especially in a worldwide context. So the point I'd like to make is that if we can all acknowledge that each platform has some sort of individual characteristics or some really strong value propositions that our users can benefit from, that I would argue that if you find yourself in a situation where you're choosing between web and native, and as part of this situation, there's also, rainbows and unicorns, and the sky is blue, you have no budget restrictions, no time restrictions, then you would absolutely build applications for all of these platforms. Why wouldn't you? Why wouldn't you want to create the best possible experience for your users? Why wouldn't you want to build really optimized applications that runs on all these platforms? It's really in your business's best interest to do so. I would also submit as an argument here, I'd like everybody in this room to take a second to think of like 3 or 4 services that you use on a day-to-day basis. So think of things that you use to watch videos or listen to music or social media or any of these types of services, maybe maps or whatnot. I would bet those services are probably available both on the web and as native applications. And in fact, if you go through lists of, say, the top 10, top 20 applications that are out there on app stores or apps that people are using, it's really hard to find an exception to this rule. Most major sites, most major services build optimized applications for their users on all the platforms that they can. In fact, as I was going through these lists, the only apps that sort of stuck out as exceptions to this rule are certain mobile apps that are really entirely dependent on some sort of hardware feature that devices have. So Uber and Lyft are not on here because they rely on geolocation on a device. They can't get by with just the web's geolocation. And Snapchat is one of the other big exceptions to this. Snapchat needs more advanced camera access, so it's not an application that's available on the web. But with those exceptions out of the way, pretty much all of these services run across web and native and usually provide quite good apps in each of these contexts. Now, of course, the caveat to this is I introduced this by saying if you're in a situation where you have no restrictions, unlimited budget, all these crazy things. And the reality is we do have those things. We do have budgets. We do have time constraints. Things get in the way. There are deadlines. And really, that's what ends up fueling this web versus native debate. Because when you are in a situation where you don't have YouTube's budget or Twitter's budget, you have to make hard decisions. Ideally, you would build really optimized applications for these platforms, but the reality is you just don't have the time or resources to do that. Now, the good news is that because of the demand for reaching all of these platforms, and because of the historic difficulty of doing so, there's been a lot of engineering muscle, a lot of engineering effort thrown at making this easier for developers, or making this problem a little bit easier. Now, there are a number of different solutions out there. Today, I'm going to focus on 2 of them. One is called React Native Web. The other one is called NativeScript Schematics. Now, just as a brief to help set the stage for how much experience this room has with these technologies, can I just get a show of hands real quick? How many people here are at least a little bit familiar with React Native? Okay, so I'd say about a quarter of the room or so. So same basic question, how many people here are at least a little bit familiar with NativeScript? So also about a quarter of the room. So for those of you that did not raise your hands, both NativeScript and React Native are ways of building native iOS and native Android apps using JavaScript. So you're not using Objective-C or Swift on iOS. You're not using Java or Kotlin on Android. React Native is a project from the Facebook team, from the React team as well. It's a project that lets you use JavaScript and also the React framework to build native iOS and native Android apps. The NativeScript project is done by us at Progress. I work on the NativeScript team at Progress, which also, the NativeScript project also lets you use JavaScript to drive iOS and Android apps, but we also let you do that without any additional JavaScript frameworks or also the Angular and Vue frameworks as well. The characterizing feature of both of these frameworks, though, is that even though you're using JavaScript to drive your apps, these frameworks are not using web views or browsers in any way. Because of that, these frameworks are actually using native iOS and Android user interface components. Oh, there it goes. So your apps look and feel and behave like native iOS and Android applications because they're actually using these UI controls that are native to this platform. This does, though, bring up an interesting challenge. So with these frameworks, even though you're writing your source code in JavaScript, the actual code to define your user interface looks a little something like this. So this code over here is React Native code. So you see view, text, card, some other user interface controls. And in NativeScript, you'll see there's somewhat similar but a little bit different markup with things like action bar, grid layout, stack layout, and whatnot. Now this is code that on the web would be things like divs or spans. But React Native and NativeScript both have special vocabularies so that they're able to render these user interface controls in an Android and iOS context. This does, though, bring up an interesting question and challenge. Remember that the whole point of this talk, the whole point of what I'm trying to show, is how you take one approach, one code base, and build 3 different applications. So both of these solutions provide ways of building 2. React Native can turn this into an iOS and an Android application, a cross-platform app. NativeScript can do the same with this markup. But this leaves out the web part of the equation. How do you turn what you see here into code that actually can run and function on the web? And one of the reasons I picked these 2 solutions today is because I think there's an interesting contrast in the approaches that React Native Web and NativeScript Schematics take to solving this problem. Now I'm going to get into a demo here in a second, but I just want to provide you with a little bit more background information on what each of these 2 projects does. React Native Web is a project that came out of the React community. It's actually primarily written by one guy named Nicholas Gallagher. He has something like 95% of the commits to this thing. He was an employee at Twitter at the time. This project is actually used for mobile Twitter, or Twitter Lite, or whatever they're calling it nowadays. And he now works at Facebook and is involved with maintaining this project on the Facebook team. So we'll look at that one first. And the second one is one I'm more familiar with, one that we've created through the NativeScript team. We've worked heavily with the Angular team to create what we call NativeScript Schematics. Now the term schematics is actually an Angular term. So the Angular CLI, the Angular command line interface, is the way you use to build, run, create Angular applications. The Angular CLI also has this API called Schematics, which is really a fancy word that just means it's their extension API. So what we do is we tie into Angular's extension API to allow the Angular CLI to not only build web applications, but also build iOS and Android applications through NativeScript as well. Now to show this, we're going to build the same basic, oops, getting ahead of myself here, the same set of applications using each of these technology stacks. So I've got a simple little checklist app. If you're familiar with me at all, you know that I am a fan of the Pokemon franchise, so I tend to use them for my demos a lot. I've got my support Pokemon with me here today. But this is just going to be a little checklist app. And I've made it purposely simple just for the sake of teaching, because I don't think trying to build like a full Twitter clone or something like that is necessarily the best way to learn the approaches these technologies take. And as I go through this demo, I'll point out the parts I want you to focus on, which is really just how each of these frameworks approach the problem of rendering the web applications, because I think it's kind of interesting. And what you're seeing here, just so you're clear about what I'm going to be building, this is going to be a native iOS application using native iOS and Android controls. This is a web app. You see I got my browser here. I'm at localhost here, so we'll be building that as well. And then this will be a native Android app using native Android user interface controls. And with each of these technology stacks, we're going to build this application using one code base, one JavaScript code base. And the last thing I'll note before I get into these demos is, this demo is purposely simple just for the sake of teaching, but that doesn't mean these are toy technologies or technologies that are not being used. As I mentioned earlier, React Native Web is being used on mobile Twitter. They've also got some impressive showcases. If you look at their GitHub repo, Major League Soccer, a few others as well are using this technology. With NativeScript and Angular, our code-sharing technologies drive the app called Portable North Pole, which is an app that gets a couple of million downloads every year. It's kind of a big deal. If you have kids, I'd recommend you check it out around the holiday season as well. And they're actually using our technology to render their application on the web and then also drive the Portable North Pole that appears in the iOS App Store and Google Play. So with that, I am going to demo. You're going to have to give me a second to switch over here because the Mac got rid of my mirroring options, so I've got to like peck and hunt here. There's my mouse. And manually switch mirroring on, so hopefully I'm seeing what you're seeing, and there we go. So the first technology, or the first approach that we're going to look at is React Native Web. And when you start with this, the place you want to head is to their GitHub repo. Don't worry about remembering the URL. If you just Google React Native Web, you'll find this. And the GitHub repo and its README are really the best place to get started. This is where all the documentation is. This is where the stuff on getting started all lives. And when you first come here, the first thing you'll want to do is head to this quick start section. And I'd recommend starting in this code sandbox template, just because it's a really easy online way you can start without having to download or sort of install anything. And you write your code here and see it on this side of the screen. But for today, if you follow the Getting Started guide, it'll tell you how to set up a local setup and get everything running locally, which I've already done, and I've got set up over here. So I will just open this up, make sure you can see it okay. And I'll talk about the actual code here in a second, but the first thing I want to do is actually run this so we can get a visual of what this looks like. Oh, not start. npm run web is what I want to do instead. And what this is going to do is run this application up in a browser and then spit it up to the side of my screen. It's a very exciting application at the moment. It just says hi. So this is the React Native. It's essentially hello world for React Native Web. And there's a lot of sort of Reactisms here. If you're familiar with React, you'll recognize some of the things you see here. If you don't worry about it. It's really not important to the point of what I'm trying to show you. The only thing I want you to note is actually in this template that you see here. So if I were writing a web app with React, I'd have something here like a div with an input or a label or something in here. But instead I have these sort of unfamiliar feeling UI components. I've got safe area view and text. And what's interesting about this is that these files are actually coming directly from the React Native package. So even from this simple bit of code here, you can actually get a sense of what React Native Web is doing. What the project does is it takes a React Native app, so an app that's intended to be run on iOS or Android, takes your code verbatim without making any changes, and renders it in a web app that gets cut off there. Let me get these side by side a little bit better. There we go. So essentially, React Native Web has web renderers for every React Native component that you write. And I'll go into a little more detail here as we start building this up, but I want to add a little bit more code so you can see this in a little more detail. So what I'm going to do is I'm going to go in and start to add some more functionality here. I'm going to start by fetching some Pokemon data, because we're going to need that to build our list. And then I'm going to introduce a handful of additional UI controls here that's just going to add a little more detail to this app. And after I save this, I should see my list of Pokemon that shows up here. Now, the couple things I want you to notice from what I just did here. The first is this fetch method that appears here. Now, fetch is a web API. This is code that runs in the browser verbatim, so actually nothing needs to happen here for React Native Web to make that work on the web. It just sort of works. But in this case, what's interesting is that, remember, this is React Native code. This is a code that I intend to share across all three platforms. So what React Native and actually NativeScript both do is provide an iOS or Android implementation of this fetch method with native iOS and Android code, so that this code continues to work across all three platforms. And you can't see this at the moment because I don't have this up running in a native context, but in a minute, I'm going to run this exact same code without making any changes in an iOS context, running in an iOS app. And you'll see that without me needing to change or fork my code, I'm able to run this exact same application in all of these places. In terms of here, all I added was a few additional UI components. One of the cool things about using this technology stack, and this applies to both React Native and NativeScript, is that even though you're working with some unfamiliar UI components, like you won't know what these things do unless you start working with React Native. All of the same sort of React isms that you might already know, for example, how to do data binding, how to work with various syntactical features, those also, they just continue to work. These are skills that you already have. And remember also that normally to build this sort of thing, if you're talking about iOS or Android, you would have to go into places like Xcode or Android Studio to implement some of these functionality, or some of this functionality. And instead, you get to do this with a JavaScript framework that you're either familiar with or that at least the learning curve is not nearly as high. So that is that. I want to add a couple more pieces of functionality. So the next thing I want to do is add some CSS. So at the moment, this list looks a little bit weird because I'm not actually applying any styling at all. Now, CSS in a cross-platform way is also an interesting story. So CSS in the browser, we know how that works. The browser has a concept of styling, it has a concept of CSS files, it has a style attribute, and you can apply CSS rules exactly as you'd expect. Once we talk about native, when we're running in an iOS or an Android context, that concept of CSS kind of goes out the window. Because remember, there is no browser there, there is no DOM there, there is no HTML there. So instead, what both React Native and NativeScript do, and I'll paste in a little bit of CSS code here just to give you an idea of what this looks like, is each technology has essentially a white list of CSS properties that you can use, and that React Native and NativeScript are capable of rendering in an iOS or Android context. So, for example, both frameworks support Flexbox and all the various Flexbox syntax, or things like align items, and all the other properties that are associated with Flexbox. But a lot of other layout mechanisms just don't work. For example, if you wanted to do display block, or display inline block, or relative positioning. These are things that are just, they don't really quite exist in an iOS or Android context. So this is one of the trickier parts of dealing with multi-platform development, is that not every concept that you know from the web is going to directly apply once you go into native app world. So the last piece of functionality I want to add to this app is I want to allow users to tap items on the screen. And so I've got an event handler set up to do this. Toggle selected. Again, don't worry about the sort of React code here. I'm probably not even doing this right anyways, but it works. And I can now select items on the screen. But the last piece of functionality I want to add is a way for the browser to actually remember those selections. So right now, I make changes, or I make some selections, but as soon as I refresh my browser, the change is gone. Now this is another chance to talk about how you attack multi-platform development. So the browser, if you want to save data locally, so let's assume I don't want to save these selections to some cloud backend or some API, that I just want to save the changes local to the browser or to the device. The web and native apps have completely different concepts of how to do this. So in my web app, I would probably use something like local storage or session storage or something like IndexedDB. But my native app, remember, there is no browser, has no concept of those things. So instead, I would do something like write to the file system, or I might use something like SQLite. Maybe if I was doing something really platform specific, I might write this data to someplace like iCloud. Just native apps opens a whole new set of possibilities of things that you might want to do with your data. So when it comes to multi-platform development, you oftentimes will find that you have some choices. Sometimes there are APIs that abstract all these platforms away for you. So fetch is one example of this. The fetch method, as I'm writing it here, is going to work on the web because it's native to the web, and also work on iOS and Android because React Native and NativeScript essentially do some work to make it that way. There are other APIs like that. For example, I'm going to show you how to use the async storage API that React Native has and that React Native Web uses as well. Usually, if these APIs exist, they're pretty convenient to use because it keeps your code fairly clean. You're just using one approach and hitting all three platforms at the same time. The other option you'll have, and you'll almost certainly hit this as you start multi-platform development, is to fork your code and to handle iOS, Android, and the web separately. So with React Native Web, the way to do this, and I'll show you on their documentation here, is they have this entire section on multi-platform apps. And there's two different ways that React Native Web supports this. One is that you can just do a simple if check. So you can say in your code, if I'm running on the web, maybe I want to do this value or do this thing. Whereas instead, if I'm running in a native context, maybe I want to do something a little bit different. Now, this tends to be nice when the change you want to make or the code that you want to diverge is small, like a line or two of code. In situations where you need to fork your code a little bit more or do a little bit more in the code you're actually diverging in, React Native Web also supports a file naming structure where essentially you create 3 files with 3 different extensions. So the .android version would have your Android implementation of whatever it is you're writing, and the same sort of thing for iOS and the web. And the React Native CLI has a built-in way of selecting the appropriate file on the appropriate platform. So for this web application, it would take the web implementation of this file and run it and ignore the other 2. Now, when I get into NativeScript, I'm going to show you an example of this. We'll dig into that sort of forking code thing a little more robustly. For now, though, I just want to finish up with this React Native app. So I'm just going to use this async storage API just because it's easy to use. And I want to finish this up so we can move on to NativeScript. And so all I'm going to do is create an array that I'm going to use to save the selections the user makes. I'm going to add a bit of code to maintain that array. So all this is doing is when the user selects an item, I'll push it into the array. When a user unselects an item, I'm going to take it out of the array. And then finally, when the data loads, I'm going to add another little bit of code to just change the selected property and essentially monitor the highlighted state of these controls. And if I head over here and refresh, you can see that the application now remembers my selection. And this is happening because of this async storage API, which under the hood is going to be using local storage. Now, what I have not shown yet is how this app also runs on iOS or Android. So I'm going to go ahead and fire that up while we wait a second here. Now, this is going to take a minute or 2 to run up because what React Native is actually doing is compiling an actual iOS application for this source code. So it's using Xcode, it's going through the full compilation cycle, and it's going to spit it out to this device over here, and you'll get to see what this looks like. So in the meantime, while this is sort of firing up, I think the last thing I have to say about React Native Web, in my experience with it, it's a kind of neat little way of rendering a React Native web app or a React Native application. So if you do React or React Native development, especially if you already have a React Native app, it's kind of fun and potentially useful to install React Native Web and see if you can get in just an easy web app from the work you've already done on your React Native source code. The only downside I've found, and this is kind of interesting, is because this is a generated web application, you might be wondering, because my code looks like this in the template, what is actually getting rendered from a DOM or an HTML perspective? And it's actually a little bit messy. So if actually, let me just full screen this. Oops, I want to full screen the browser. Fire this up. And you can see what I mean if you start to zoom into this, right? So part of me knows that I'm not supposed to know that this is here, right? I'm not supposed to be picking into this and really digging into this. But the web developer in me can't help but think that this is a little bit messy and a little bit awkward to deal with. It also breaks up my developer workflow. At least what I do for my web development is I open my developer tools in either Chrome or Firefox, and I start tinkering with these properties over here. And this approach sort of totally messes with that, right? It's not something I can reasonably do, and instead I'm writing code directly in my editor. But that being said, it's kind of slick if I open up here on iOS that from this single code base, so again, I haven't made any changes to this code whatsoever, and now that this iOS application has come up, I now have a totally functional iOS app. And this is even using native iOS components, so you can see my scroll behavior is great here. I get built-in functionality, like I tap here and I go to the top of the list. I could easily make this like a pull to refresh type list, an endless scroll. All of these things are natively built into these controls. So that's the sort of short story of React Native Web. Again, the part that I really want you to focus on is its approach of just generating a web application from the UI components that you write here. Because as you'll see in a second, NativeScript Schematics actually takes a pretty fundamentally different approach to solving this same problem. And so, to show that, why don't we head on over and look at how NativeScript does this. So this is the NativeScript documentation, docs.nativescript.org. And if you're interested in getting started with NativeScript schematics or using NativeScript to build for multiple platforms, the thing you'll want to do is head to this code sharing section that appears on the bottom left-hand side of the screen. Now, as I mentioned earlier, we've, at the NativeScript team, worked with the Angular team to make this code sharing option really a possibility. And so if you go to the section on creating a new project, you'll see that there's a few dependencies you're going to need to have in place. The first is the Angular CLI. So NativeScript Schematics builds on top of the Angular CLI. So we're going to be using this Angular CLI to create these apps and also to build and run them as well. You'll also need NativeScript Schematics, which is also coming from NPM as well. And this is going to be what ties into the Angular CLI and is going to give us the ability to run these web applications on an iOS or Android application. The command you need to use to create new apps is ng-new. This is the exact same command that you would use to create a web application with Angular really in any context outside of the NativeScript one. The -- collection flag is the magic here, though, because that's what's telling the Angular CLI that NativeScript Schematics exists and to use it as part of your project. And to see what that looks like, we'll start developing this app. And I just need a second to bring over my stuff here. So take my terminal, we'll grab this, and we'll grab this emulator as well. Now in my app here, I'll close this, and I've got the NativeScript app in this same folder. Now I'll start here, I'll show you some of the files that make up this application. I'll start by saying, as we go through this, I mentioned at the top of the React demo that if you're not a React person, don't worry too much about if you don't understand everything that's going on. The same is going to be true here if you don't have Angular expertise. Don't worry if you don't understand every little thing that's going on, because it's not super important. What is different is the way of actually rendering the web app of this. And to show that, I'm going to start just building this app. So I'm going to go into this NativeScript folder. And the first thing I'm going to do is use the ng-serve command, which is just part of the Angular CLI, to build the web version of this project. So this is going to feel a lot like any Angular app you would build ever, right? It's just a straightforward Angular application. And after this loads, I can go to localhost, and I again see my super simple or super complex starting point for this app, which is a simple hi. What I'm also going to do here, though, is I additionally want to run this app in some other places as well. So I'm going to run the tns run command. Now, TNS is short for Telerik NativeScript. This is the NativeScript CLI. It's what's going to allow me to build this exact same application for iOS and Android as well. And by omitting, I could use TNS run iOS, TNS run Android, but by omitting the platform, I'm actually going to be able to build, oops, I didn't want bundle. Wanted a separate flag as well. We'll see if that finishes on me. Bundle, I want HMR instead. But what that's going to allow me to do is run this app on multiple different devices. So we'll see if we can get this to run both on the web as well as this Android virtual device and this iOS simulator as well. And in theory, I'll be able to run on all of these devices. Now the HMR flag that I used, it's a new feature that we just added to NativeScript in the latest version. It's short for hot module replacement, which you might recognize if you've done any Webpack work before. So what we're doing is using Webpack under the hood and giving developers the chance to develop your apps and see your changes really fast. That's really all you need to know. And the way you'll be able to see this, and sometimes I have to make a small change to kick this into place, is just how fast these devices update as I'm making my changes. So you'll be able to see it here. This should reset all these devices. So there's the Android one. I think the iOS one is still firing up and running. So while this finishes building the iOS app, I'll walk you through a little bit of what this code is doing. So this is the main component that builds this application. And as you'll see, and unlike React, this is sort of just a React versus Angular difference. Angular sort of recommends that you put your templates for your code and your CSS in separate files. It's not a NativeScript or React Native thing. It's just a React versus Angular thing. And so I've put those files into separate files over here. And when I look at these files, this will actually show you the difference between React Native Web and NativeScript schematics. So notice right away, remember when we looked at React Native Web and we looked at the file naming convention, you can see that I'm actually already doing this for my NativeScript application. So unlike React Native Web, with NativeScript schematics, we're actually forcing you to write your markup and your CSS twice. Once for the web and once for your native applications. So we do not auto-generate your web app. Now we think this is a better approach just because it means you'll have a lot more control over the web apps that you are building. The downside is you do have to write a little bit more code because instead of having your web app just generated for you, you're explicitly providing the code for that platform. I think my iOS app here got stuck, so I'm going to try this one more time while I'm going through this, and we'll see. It flipped and it flipped back. Yeah, we'll see. Give it a second to see if it does it. Otherwise, we'll just stick with Android throughout this. And so what I'm going to do is I'm going to start building up this application. I'll give the CLI a second here to see if it can figure out iOS. And what I'm going to start by doing is I'm going to bring in a service. So the Angular way of sort of accessing HTTP-based APIs is through a service. So I've got a little service here that's going to allow me to get data. Are you there, iOS? Okay, I think you're there. We'll hope we're good to go. And then I'm going to write a bit of code in here to actually hit that service and go grab my data. Now, the Angular way of approaching this problem is when you have data, you put it essentially as a property on your component. So I'm going to get my Pokemon data, and then I'm going to store it in this component. And then once it's stored in the component, it's available for my UI to essentially bind to and for me to use as part of my apps. Now, unlike React Native Web, where I would just provide my React Native UI components, for this NativeScript schematics application, I'm going to need to provide my UI twice. Once for the web version of this application, which is running here, and then once for both the iOS and Android versions of the app that are running here. So what I'm going to do is I'm going to go into the non-prefixed file, so just the base HTML file for this app, and I'm going to paste in some vanilla, it's NS, vanilla Angular code that's just going to loop over the list of items that appeared there and just display them in a simple LI. And you can see as soon as I save that, it's kind of behind there, but I can now see my Pokemon data here, and that only my web app updated. So the CLI and the Webpack setup is smart enough to know that only the web version of this file changed, so shoot that change out to the web, but leave the native apps alone. If I then go in and go into the TNS version of this, which will be the NativeScript version, I'm going to put in the NativeScript equivalent of these UI controls. So I'm going to do a simple list view. And when I do that, you see HMR takes over. It displays this application. I don't know what happened on Android there, but I get this amazing list of Pokemon that shows up here. This is one of my favorite little quirks of iOS. If I display data in a UI table view and you don't give the image dimensions, it doesn't try to contain the images, it just lets them overflow. So you get this fun little awkward display that shows up here. I think Android froze, so we'll just stick with iOS and the web for now. Now you'll see that like React Native, I use some NativeScript user interface components. I again use Flexbox. It tends to be the most consistent way that you can lay out your apps both on NativeScript and the web as well. But really what this allows me to do is just have more control over my app because I am providing my web implementation in one set of files and my native implementations in another set of files as well. Now from there, what I'm going to do is go into my CSS. This is again something that I have to provide separately. So I'm going to go in and change the CSS for the web first. And you'll see that as soon as I save that, I see a basically preview of what this application looks like. Now at this point looks pretty much exactly like the React Native web project. And in here, I can write any CSS I would like for the web. So with React Native Web, I had to be a little bit careful in terms of which CSS properties that I use, because not all of them are going to work with React Native. But with this NativeScript schematics approach, this is just CSS as you know from the web. So you're free to put anything you'd like here because you're writing web-specific code. In my NativeScript version, though, I do have to provide only the whitelisted list of CSS properties that NativeScript provides, which is in this snippet here. So things like padding, things like flexbox, background color, height and width all work, and you'll see how fast my iOS simulator there updated to show these changes. So this is sort of the advantages that we see in having this forked approach, where you still, if you think about it, in this application, I'm still sharing a whole crap ton of code. So I have all of my Angular plumbing, my routing, all of this is shared, my components, my service that actually goes to hit my backend data. But then I'm painting essentially the user interfaces in two different ways, once for the web and once for my native apps for iOS and Android. And we think there's a lot of power in that. Not only, keep in mind again, I'll probably say this 2 more times, that the equivalent of building this application is something you'd normally have to jump into Xcode to do and write some Swift code or some Objective-C code and figure out how to provide this styling and how to provide tap handlers. Whereas with using this technology stack, you're using Angular to do that. So this is something that you already know how to do if you've used Angular before, or something where the learning curve is far lower. You can learn Angular if you're a JavaScript developer a lot faster than you can learn how both Xcode and Android Studio and those entire platforms work as well. And you still get some powerful apps for all of these platforms. Now, the last thing I want to show is the same bit of functionality that I showed with React Native Web, and that's allowing users to select items in the list and also remember those selections. Now, if you remember back, I said that with React Native Web, I was going to show you how to do it with one API, an API that was going to work across all 3 platforms. But with NativeScript, I wanted to give you some idea of how you could fork your code. Because when you build apps like this, when you're building for multiple platforms, you're inevitably going to hit situations where you have to do something different between the web and between your native applications. So one way you can handle that is if I go in and I'm going to go into my list component, and I'm going to add a small tap handler that's going to call off to my Pokemon service, which I'm going to open just to show you the approach I'm taking. And I'll go ahead and full screen this thing for a minute. So what I did for this file is instead of using an API that abstracts me away from the platform differences, I wrote this file called Pokemon Helper. And this is what I'm going to use for file storage for this application. And the approach I took is, if we go into the file system here, I've got a helper both for my NativeScript app, for my native iOS and Android application, and one for my web app as well. Now the web app one is a lot simpler, so I'll start there. Really, I just wrote a really lightweight wrapper of local storage. So when I read items, I just get them from local storage, do a little parsing logic. When I write items, I use local storage to set those items. I could switch out this implementation with anything that would work on the web. So if I wanted to use session storage, IndexedDB, or whatever the case might be, I'm controlling web-only code at this point. On NativeScript, I have some other choices. So for this example, what I did is I just used the NativeScript file API. So NativeScript has a bunch of built-in modules for doing common native tasks, common things that you might want to do as part of a native mobile app. And one of them is write to the file system. So instead, in this context, I'm saying, when you save, write that text to a file and give it a file name. And then on the read, I go ahead and read those items from the file system. Now, like on the web, where I could switch that out, I could switch local storage out with any web implementation. Here, I could do native-y things. So I could read and write from SQLite. I could read and write from iCloud. I could do any things that native app provides. NativeScript, we also let you tie into native iOS and Android APIs. So I could actually just start writing iOS and Android code here as well, if I was really familiar with those platforms. If I really wanted to get platform specific and something advanced, I could drop down to that level of detail if I needed to. But I could also just keep things simple when I have a simple example. This example is purposely simple, so I have no need to really overcomplicate this. And now I have an app that should work fine if I refresh. And my iOS app here should work as well. I'm going to try to resurrect Android here. I'll run this specifically on Android just for the next example. And what I want to show is, so to this point, I mean, this app is really simple, right? Your next production app, I don't think your boss is going to come when you get back from DevReach and say, so I've been thinking, and you know, the next app we need for production, we need a Pokemon checklist app, right? I don't think your boss is going to say that. If he does, you know, contact me because I might be interested in checking that out. So most cases, you need to do some more advanced stuff. And what I really like about this multi-platform approach is that even though it enables you to do some pretty cool things, right? I'm building 3 applications from this one code base. I'm never prevented from taking advantage of the best of what these platforms have to offer. For example, this is just an Angular web app at the end of the day. So I have an index.html file. I could totally add a service worker and turn this into a progressive web app. There's nothing preventing me from doing that. This is just an Angular CLI application. I could take advantage of any API the web has out there if I wanted to. I could fork my code to make sure I don't break my native apps, and I could hit these web APIs to do specific webby things I need to do. I could write entire pages that only appear on either the web or native apps. Maybe I need an admin screen on one platform but not the other. I think where things get more interesting, though, is I could take that same approach on the flip side. I could do native things when I need to and just avoid doing them on the web. And I think it's better to show this with a few specific examples. So with NativeScript, we have this thing called NativeScript plugins, which is really our way of helping developers do native-y things in code. So you have a NativeScript app, and you need to use the camera. Well, there's a NativeScript camera plugin. You need to do geolocation. There's a NativeScript geolocation plugin. But there's some interesting ideas that you could take here for building multi-platform apps as well. Suppose your application needs a login screen. A whole lot of applications do. What you could do is you could write your login screen for the web exactly as you do today. You could share your code for actual user management, token management, your models, your services, and whatnot. Then for the web, you could build a fairly basic login screen. And for your native apps, you could optionally add on something like Touch ID or Face ID or fingerprint authentication to provide that nice little extra benefit for your users that happen to be using your application in an iOS or Android context. You could also, for example, suppose you wanted to provide Facebook ID or Facebook logins through like a login with Facebook button on your native application. With this approach, you could use the actual Facebook native iOS and native Android SDKs for doing that and enhance the application for your native users without breaking the experience for your web users. The last example I have, and I think there's literally 1,000 plugins on this, so I could keep going at this all day. But imagine that you need to add a map to your next application. You could use a web-based map for your web application and use one of our plugins to put something like a Google Maps native app or a native map in your native Android or your native iOS application. So just because you're using this platform that lets you build 3 applications at once, it doesn't mean that you're necessarily compromising the experience for your users. In fact, you're still able to leverage the best of what these platforms individually have to offer. Now, I could show you something serious and add something serious to this app, but if you've caught anything about my demo methodology to this point, you might know that I don't typically do very serious things. So the plugin I chose to use is a plugin called the NativeScript Explosion Field plugin. Now, what I like about this plugin is first the fact that somebody felt the need somewhere to write an Android library that just takes any arbitrary view and makes it explode. That's really all the thing does. So I think it's awesome that somebody on the internet felt the need to do this. And somebody in the NativeScript community said, you know what? This Android SDK needs to be a NativeScript plugin. So they wrapped it in a NativeScript plugin, provided TypeScript typings for this thing, so that any NativeScript developer could make things explode in their own applications, which is kind of nice. Hooray, open source. So what I did is I took this plugin and I installed it in this application. So NativeScript plugins run off NPM, so it's just a straight up NPM install. Now NativeScript Schematics, which is kind of cool, is smart enough to automatically exclude these plugins that you're only using on one platform or the other, meaning I don't have to do anything special to make sure this doesn't break my web app. Webpack and NativeScript Schematics is smart enough to not bundle up these NativeScript plugins in with my web application. The same is going to be true the other way around. If I wanted some JavaScript library to use on my web app, I could use it as part of my package.json here and know that it's not going to break my NativeScript app as well. So I have the NativeScript Explosion Field plugin. I also have this audio plugin as well. And to use this, let's see, first of all, let's hope my Android, if my Android device doesn't work, this is going to be a little less fun, but we'll see what happens here. What happened to Android? Hot module replacement enabled. So we're going to try just TNS run Android real quick to see if this works, because this is an Android plugin, so I won't be able to run it on my iOS simulator. It's doing Android-specific things. So I'm going to give that a second to hopefully kick into gear, because we don't want to miss the explosions. That would not be fun. So I'll make this a little bit bigger, and I'm going to paste in the code that's actually going to use this. Here we go. I don't know why I'm not seeing data, but we'll see if I can make a change here and kick it into gear. So I'll save this, and come on. Couldn't retrieve the data source. Is it like that I don't have internet or something? That's weird. So I'll give this one more try, and then unfortunately we'll have to, do I have internet? I have internet. So I also have, that is really weird. It's not getting the data back. So I'm not going to dwell on this too long. It is a little bit unfortunate that it's not able to retrieve this data. It's not very fun. So I'm going to try one last thing. So I've got a local version of this data that's on my desktop. So my favorite command is creating a simple local server, simple HTTP server. So I'm going to host this file locally so that instead of getting it from an endpoint, we'll see if this works. If my Android app likes this as well, hosting locally as well. It doesn't like it. So unfortunately, we might not be able to. 8,000. This is everybody's favorite live debugging here. All right, so I don't think this is going to work. I don't know. It's really weird. I don't know what went wrong here. I'm going to try one last thing, and while I go through my last things, and we'll see if we're able to come back and see our explosions here as they were intended. Actually, it should work. It's up there. So I'm going to try this one more time. So in any case, what we should see is some explosions happening here. But regardless, the bigger picture here is just what is possible, what I said earlier. You know, if you think about what you'd normally have to do to build applications for 3 different platforms, you would have to go into 3 separate tools. You'd have to go into Xcode, you'd have to go into Android Studio, you'd have to go into a number of different platforms to make this sort of thing possible. And with approaches like React Native Web and NativeScript Schematics, you're able to do this from one single code base and one single set of technologies. And to wrap up here, go to my demo and go ahead and play that. If you're interested in getting started with React Native Web, as I said, if you just Google React Native Web and find the GitHub repo, that's going to contain everything you need to get started. For NativeScript, if you head to docs.nativescript.org, you find this code sharing section at the bottom of the screen. That's what you're going to need to get started with NativeScript. One thing I should also mention, I've focused on NativeScript Schematics from just starting a completely new application from scratch. But Schematics also has a way, if you have existing Angular apps, to extend those with a native application. So there's ways of essentially migrating your existing Angular apps into a code sharing structure that is possible as well. And the last thing I'll add is that a lot of people also ask me which of these approaches is better. Is it better to use React Native Web or NativeScript Schematics? And usually I answer this by saying there are some, if you have a framework preference, if you're a really strong React person, if you've been using React for a long time, I think you'll more naturally gravitate to React Native Web because you'll just feel more comfortable in a React ecosystem. The same is going to be true with NativeScript schematics and Angular. Just knowing Angular framework and some of the backbone of this technology is just going to help you get up and running. I think the more interesting question, though, is which approach is better in terms of, is it better to take a React Native app and generate a web application, or is it better to take the NativeScript approach and write your native application and your web application separately? And for that, I don't necessarily have an answer for you because it's sort of a personal preference sort of thing. In my own experience, I found that the React Native web approach is actually really nice when you're building simple applications. It's really kind of cool to just take a React Native app and generate it for the web and see what it looks like. It can be kind of easy. But it gets hard when your apps get more complex. On the flip side of things, NativeScript schematics is really good at handling more complex use cases because there's lots of abilities to fork your code and handle those sorts of more advanced situations. But schematics can be a little bit verbose for simple apps. You saw just the sheer number of files that were a part of your application, and you don't really benefit from that if your application is really quite simple. So I am curious what you think. I will be around for the entire conference. Come chat with me if you found any of this interesting or you want to talk more about this. Now, before I leave, I'm just going to one last time check this application just to see if we're running on Android. So if you want to see exploding Pokemon with noises, I can even play there was supposed to be exploding Pokemon with noises, but it didn't work. But come grab me if you want to see that later. So thanks. Does anybody have any questions? I think we do have a few minutes. Yeah. What was that? The exporting library? Oh, I'm not sure what you're referring to. I'm sorry, I don't totally understand. Oh, the exploding library? No, it's not my own library. No. I'm actually not sure who wrote it. All right, if anybody has any other questions, you can come chat.